How is everyone? No, I'm not sure if you can see very clearly from there, but in the past week I was not feeling very well, but I'm fine. Today we can do our class. So anybody to recap in the previous lesson, the last lesson, what we talked about before we proceed to today's lesson? Come on, guys. No one wants to talk. Unbelievable. Yes, Brian.
Okay, last lesson we talked about logic. We said I don't remember manga that there's an evidence all of it, not exo none.
Wonderful. Thank you for that. Is there anyone who remembers anything else from the previous lesson? Yes, Kuda.
We talked about RAM, the random access memory. It holds information. The information can operate at that time. That's where the information will be stored. And then we also talked about process CPU, which manages all the activities of the computer, both hardware and arithmetic.
Okay, thank you. So it's good that some of us at least still have some recollection last week. Now, I don't know if you've been making any progress wearing a Buguri area, but how do you know? Because I've got an assessment for you that's coming up. I don't know what wearing. Pana challenge. Hapana didi. Let's try to finish that book. Say, why do they work the way they work? Okay, so schedule. We were supposed to do deep dive computer software last week and did it. From the 27th, we were supposed to be talking about systems software, application software, cloud computing, visualization, approaches to developing the future of software, closed source versus open source, then talk about critical and analytical thinking challenge. I did it. So because we lost the week to other activities, of course, we want to try and do what we were supposed to do while at the same time catching up with what we want to be doing, because ideally our dates curriculum. So for instance, NASMA R31, we are supposed to be doing Web 101, where we talk about internet architecture, we talk about e-commerce, e-learning, e-governance, social engines, social media, search engines, collaborative spaces, and all these other things. We want to try and do what and at the same time catch up with the new content I did. So what do you think of? Anyone, what do you think of if you hear the word system software? What do you think of? What is system software? It's a question, guys. You need to answer. You can also say, I don't know. Yes. The type saying, Clemens. Okay,
Yeah.
Clemens. Make it a point to know Garaiba Papa Chet or such. Yes, Clemens.
I think of programs and documentation.
When you hear the word system software, you think of programs and documentation. Okay, anyone else? Guys, come on now. Yes, the lady at the back there. Dianigo. Dear Emily. Hi, Emily. How are you?
I'm fine, sir. Software, these are instructions, or we can say programs that manages the operations of the computer, or we can call them operating system.
And
so for a computer, it should have an application, or it should have a system software or operating system.
Okay, fantastic. So I think you've got a good understanding of system software. Basically, system software, it manages my resources in a computer. It allows you to actually utilize a computer. So you find my programs like any operating system, or even be it a relational database management system. In a database, so you know the engine. Those are examples of system software because they run their underlying Pazasi and they can be utilized differently and So what about when we say application software? Application software, anyone? Yes, Emily.
Application software, I think these are programs now that enables us to do it on the computer. For example, some word processing software, some database presentation software.
And so I don't know if we all get the distinction between system software and application software. Do we understand the difference? Brian, who's that one sitting next to you? Lorraine, do you understand the difference between system software and application software?
It's not yet clear.
It's not yet clear. Then you should tell me, because when you keep quiet and I'm asking, I will assume and then you get out of Boyenda, and it's a problem, okay? So basically, application software is software in something specific. That's why app. What's up? I don't know what's up. So they made a funny play on saying what's up when you're greeting someone, and then they said what's up with the app that comes from application. So you have your Facebook app or your Instagram app, so it's an application. When you say it's application, you apply it to a specific use case. You use it for a specific thing. That's why it's called application software. Then system software is actually used by the computer to manage the resources. And you'll find that many times application software is installed on top of system software. So if you think of that picture in your head, I don't think you have much challenges with distinguishing between system software and application software. So we can develop system software or we can develop application software. You'll find we'll be developing mostly application software because to solve specific problems. So we know that, for example, Mrs. Zimunya was talking about the one-stop shop And I think Mr. Mtemela also talked about it, did he? So it's an application, but then where you install it now, you probably install it on an Apache server and it running on CentOS Linux or some other variation of Linux, or you can put it on a Windows server and it. So that's system software. So you need to keep that distinct parallel in your head, so that when we start talking about apps and we start talking about operating systems, you're able to actually tell which is which. And let's talk about cloud computing. What gets into your head when you hear cloud computing? Anyone? Cloud computing. I don't see any hands that are raised. Is that because we don't know about cloud computing or we've never heard about cloud computing? You people are kidding, right?
Hello.
Yes, Tatenda.
Hello.
Yes, Tatenda.
Yeah,
Go ahead.
it is something to do with data storage. I think it's something to do with data storage.
Okay, now the storage is a specific function of a component of a computer system. So a computer system is, I think you remember from the last lesson, we stripped down a computer, right? And we showed you the RAM, and then we talked about the motherboard, we talked about the processor, and then we talked about storage, where we talked about hard drives, right? I think the computer didn't have a hard drive, if I'm not mistaken. But then someone else showed us another hard drive. I think it was from a laptop, yeah. So it's an aspect of cloud computing in that as part of a computer system, you have storage. But computing and storage are two different functions of a computer. So storage is basically putting your stuff right there, and then it stays right there. So I know you people like to save your stuff, like you get a picture with your loved one or something, and you put it in the back of the gallery there. I did it. So that's storage. I did it. Sorry, just a second. Something is sounding. Okay, sorry about that. So that's storage, I need it. The other aspect of it is the computation aspect. So computation aspect is where the computer actually does work. It's not storing anything for later retrieval, but rather it's performing calculations. So an aspect of cloud computing, because we're talking about computers as a whole, definitely, yeah, it involves storage. But you find that cloud computing covers all aspects of computation. So I see there's someone who's just written in the chat, it's Fred, who says the use of internet services for data storage, creation of programs and services. Okay. In a nutshell, yeah, that kind of caters everything. With cloud computing, what you are basically doing is, the word cloud here is, you know, the same clouds that we know. There is this abstract understanding of saying, even though a lot of the cables are actually running in the ground, and some of them are actually, you know, coming by copper wire, we assume that the internet runs from the cloud. That's to say, it runs from the air, from the sky. That's because maybe there's some satellites as well, which are up there. But it's all our computation and all our day-to-day usage of computers moving from a physical machine that is residing or is resident in an office or in my place, where we take all the computing power and we access it over the internet. The actual computers will be sitting in a server farm somewhere. I don't know if anybody has seen an example of a server farm, but I can quickly show you a picture. so that you see what a server farm looks like. Where is it? Where is it? Where is it? Where is it? Okay. So I'm just going to share my screen briefly so that you actually see. Okay. If you take a look at this picture right here, this is a server farm, this one right here. The interior of a cloud data center. So it's mostly just servers, a lot of servers, and a lot of storage, and a lot of networking equipment that is put together. I have had the privilege of going to the Tel 1 data center, which is here in Harare. I think it's the biggest data center in Zimbabwe. And you'll find that there's a lot of computers in there. Okay, maybe when we say biggest data center in Zimbabwe for the government, because I believe some private companies as well and some banking, some banks, they've got larger server farms, maybe, I don't know. So can you see my screen? Can you see these servers?
Yes.
Yes. So basically you get into this room, computer akawanda, and screen. Of course, when you need to manage a specific server on a particular cluster, you can go there and then put a monitor, hook it up with a keyboard and stuff. But basically, these things are set up and then they are left to run. So within all these huge computers, you find my programs, there's application software running on the systems as well. So you can access some services or even use them as though you're using your computer. I don't know if anyone is familiar with Office 365. How many people, show by a raise of hands, could Office 365 is here? How many have encountered Office 365? Okay, I don't see anyone raising their hands, but I'm sure we all know Office 365. Come on, we use Microsoft Word, don't we? Now you are able to shandisa Microsoft Word and save a document in the cloud. That's to say you save it on a server that's somewhere. But then when you log into your account, you can save the document and then retrieve it. So that's the concept, that's the idea behind cloud computing. So this introduces, you should take notes on this one, because pana anonzi ma SaaS ne anonzi ma PaaS. So anonzi ma SaaS, has anyone ever heard of the word SaaS? Has anyone heard the word SaaS before? Anyone? Okay. So when they say SaaS, they're talking about software as a service, okay? And basically in commerce, we have two kinds of things that you can sell. You can sell a product or you can sell a service, right? So a product would be something that you can package and physically deliver or physically supply to a specific place. But then a service would be something that you actually do or something that you allow a customer or a user to enjoy for a specific duration or for a period of time. So you'll find that products, they can be owned perpetually, like you can give it to the owner, they buy it and they own it. They then own that product. But with regards to services, people only enjoy them for a specific duration. So software as a service and then PaaS, which is platform as a service, these are kinds of architectures that allow people or users to enjoy software products as services. So you won't actually get the product to get the software product, but rather you can access it in the cloud and then pay for that access. And then once you're done, you basically log out. So this is a new model, or maybe not new, but it's becoming a very popular model among the software providers, because they then compute everything in the cloud, and then you only get to access it as a service. Are we still together?
We are together.
We are together. Ah, fantastic. Sure, Lorraine. Wonderful. Okay, it's great that we're still together. So that's the crux of cloud computing, right? Because hardware, I don't know if anyone has heard of Moore's law. Moore's law. This one, which I've just typed. Has anyone ever heard of it? Ah, come on, guys. Someone Google it or something, because no doubt answer for this one. Okay, anyone have a computer and internet? Now go Google out Moore's law. Pana you want huh? Inina this could type on my hands are here. Don't know what you mean type. One of you guys just type it at so it's oh, I see what you mean. So it's M-O-O-R-E. That's George Moore. Yeah.
Moore's law.
Yes.
Moore's law is a term used to refer to the observation made by Gordon Moore in 1965 that the number of transistors in a dense integrated circuit doubles about every 2 years.
Okay. Panas now we see say zvaverengwa na Brian.
The number of transistors in a dense integrated circuit doubles about every 2 years.
So can you imagine? This is an observation that was made in the 70s, and up to this day, it's still true. So which means my processors are more and more and more and more powerful. It's almost exponential. Every other year, every other release your processor is going to pack significantly more power, right? So this means that the hardware that is being produced, Mazano, is extremely capable. So because it's extremely capable, it's a new business model where you then say, because we can build a data center with such hardware, and let's build it to rent out computing power. And that's why you find there are people who are mining Bitcoin, is an example. Pama servers, yeah. They can build a rig, they can build a farm, they can mine crypto, because you will find when we talk about crypto, maybe in the next lesson, you then see it uses a lot of computing power and graphic cards and also a lot of electricity as well. Process it because it's now cheaper. But back in the day, if you looked at the hardware, for example, I don't know what my floppy disk, but I know here. You know, I had the privilege of using a 5.25-inch floppy disk, and it was so big, but I changed it at 20 megabytes the data. And this is you can put SD card game phone. You can put what? 64 gigabytes. Or some phone marco. What is the music? And did it? So hardware is becoming more and more capable. And because it's becoming more and more capable, you have a lot of companies that have the money and the outlay. You could take hardware. But you take hardware, and then they install my systems, and then they allow people to access the services. Because from on my level as a consumer, I may not have the computational power that I need. I need it. Running out algorithm yangu yekuti predict some machine learning model yandagadzira. But rather, I can come to Amazon, I can go to Amazon, AWS, or Microsoft Azure, and then I can put my model there because they already have the big servers ready and waiting. So that's the idea behind cloud computing. It allows you to utilize hardware that is configured by experts. Because you find the people that set up these things, Ziyama bottleneck ASA, and they configure them to run so smoothly. So that you can with whatever specific task that you want to do. And then the other aspect is virtualization. I don't know if anyone has ever heard of virtualization. Virtualization. Or has anyone ever heard the word virtual reality?
Yes.
So tell me, you are the one who knows. Tell us, what is virtualization? Tell us. Kuda, come on, tell us, what is virtualization? Feel free. I don't know. Is Tisabi here? Aripo.
I know about virtual reality. I know about virtual reality.
Tisabi Aripo.
Yes.
Oh, you're there. Yeah, because we don't want him to miss out on the definition, but it's okay. I'll come after him in English. But you can shoot. Go first. Yeah, Tauratins.
Yeah? From virtual reality and it's more like it appears as if you are somewhere else, but you're not. Says on movie house these days. I don't know that thing they make you some I don't get one in that whole set. So I'm not so sure could you kind of see visualization in line in that same concept or
okay. Well done for giving it a go. Okay, basically when we talk about virtualization and we are talking about computer software, right? There are certain programs that are used to create simulations of computers. Okay, so I've got my computer, I'm running Mac OS, right? That's my operating system, Mac OS, that's the Apple operating system. And I want to use maybe software that is specific to Windows, the Windows application. What I can then do is I can go online and I can download software that is called VMware or software that is called VirtualBox, right? When I download it, what does it do? It's an application software, right? And did you remember when we talked about system software and application software? Did it? So system software is Mac OS. That's my operating system that I'm running. Then I go online and I get VMware or VirtualBox. That's application software. Then what do? I install system software inside that application software. So that allows me to run, say, Windows inside of VirtualBox, inside of macOS. So it allows you to build a simulation of a computer. It's a software-defined computer. So you can actually say it's got 32 gig of RAM, it's got 100 gig of storage. You define it in software, And then you can actually run it inside another computer. So you can actually have clusters, and you can even build a network of these software-defined computers. So it's another technique that is used, particularly in these server farms where, you know what, they've got one big server, right? But they know that they need maybe 10 computers, 5 that are running Windows, 5 that are running Linux, something like that. So instead of actually going out to buy the physical computers, we'll then build what we call the virtual computers. So these virtual computers are built inside of virtualization software. So examples of virtualization software, that's where we talk about VMware. That's where we talk about, what's it called? VirtualBox, right? Those are just examples, quick examples. There's also Parallels. I like Parallels. It really simulates a Windows machine very well on an Apple macOS environment. So that's the idea of virtualization. So can anyone give me an example, or maybe give us a situation where it would be ideal, or it would be a good idea to virtualize, right? Just a quick example where you say, you know what, this is a perfect candidate for virtualization. Yes, sir.
Visualization is mostly used by engineers. For example, if they want to build a bridge, they will visualize, see if the bridge will be possible to build.
Okay, so the context in which I'm talking about virtualization will slightly differ from simulation, because you are definitely talking about simulation. When you simulate, you're taking the properties of a specific subject and then exposing it to its environment, and you put all the parameters. So definitely, if engineers are building a bridge, they're going to use simulators. So virtualization is not always synonymous with simulation, because in this case, we are superimposing one particular technology within another technology. So probably when we're building our simulator, we may be doing it on the wrong platform, but because we want to be able to do it, we can then virtualize. By virtualizing, we create the correct environment, but within an incompatible environment, so that we can then see those results. So yeah, there is an aspect of simulation, because you are basically replicating the physical attributes. So the storage, the memory, well, maybe display size. You know, if you've got a big screen, you can even define the pixel density to say, what is the display going to be like? But that's not necessarily always related to the simulation aspect, because when we're talking about virtual, we're also trying to experience what we have then built in the manner that it functions. I don't know if we all can understand this or if it makes sense. Lorraine, are we still together?
Yes.
Fantastic. Trisha, uri kunzwisise zvokuti ndikati nditsanangurire zvandataura unogona kunditsanangurira? Hausati wapindura. Hello? Fantastic. That's good then. I did it. So that's about virtualization in a nutshell. Of course, when I come around, because I think I'm coming there, if all goes well, I might be there on Friday. If not on Friday, then next week, Monday. But I'll make a best effort to come there as soon as possible. I would like to demonstrate some of these things to you, so that I know you've got a computer that's running maybe Windows, and then you have a program that runs on macOS that you want to use. You can actually put a macOS inside your Windows through virtualization. You can put a Linux in your Windows through virtualization. So those are some of the things that you can do once you become a more advanced user, right? So the next thing we want to talk about is approaches to development. Okay. Pardon?
The question is, but each
Yes.
visualize, and is it the same thing as like the visualization to be imposed to transfer system macro is but to double an application in another window? Is it the same thing that's also done? Say, add my visual lines. Can we also talk about the recent visualization? Can you talk about my visual lines?
My visual lines happy.
As in 17 for example, and what they do to data center, they connect their lines. They are not physical, but the connections emanate. This node, they appear to have a physical connection there, but there is no physical connection.
Okay, so yeah, that speaks to the aspect I was talking about earlier, where you say you can actually build a network virtually. Like Panenge a server, did it? And then they install Red Hat or something, and then they put VMware. Once you put VMware, Papapo, you can now actually design a whole cluster of servers where you can even connect them physically. What would I connect a fiber channel? Copper or whatever. You actually define it in software and it performs as though it were physical, but it's actually software defined. Yeah, so you have a very good understanding of virtualization. That's the idea. Yes, exactly. This was what changed. Okay, any other questions? Okay, feel free. My lessons essay and up on YouTube. So when you think it's a little fuzzy or you need to, play a game or something else, link your channel. You can always go back to YouTube and play it. Go to that specific section where you probably missed something, and listen to it all over again. And then I hope it will help somebody. I did it. Unfortunately, teaching just a brief walkthrough where I'm not presenting anything. I'm not putting out any notes or sharing any links or any content. We're doing an overview because we want to be ready for when we start getting into the content of the program, right? So there's approaches to development. So by approaches to development, I wanted to highlight the fact that people can work on software as teams, or people can work on software as individuals. So that speaks to the approach to development. And then there's what we call design patterns. We will cover design patterns a little bit later, where we talk about the experience that is gained by developers as a whole. And when you learn, you know what? When we do a one-time password, we should send it by text message. It's now overly accepted throughout because of the experience that so many developers have gone through. So my best practices. So these best practices, they form these design patterns, right? I also wanted to talk about the future of software because you'll find that there's a lot of debate now where people are worried that they will lose their jobs. I don't know if you've ever heard of my accountants, for example, that there's now applications that can do accounting better than any person in the world. So people tend to lose their jobs. But then again, there's also software that is writing software now. I think Amazon just released they've got a suite of services, like, for example, Code Guru, Amazon Code Guru. It can actually take a look at the software that you write and determine to say, you know what, this is poor software, it's poorly written, or it can actually assess and say, this is good software. So you find more and more collaboration, as more and more collaboration is happening, people are going to start to rely more and more on the machine learning models that have been built on the back of all the software that is available on version control platforms like GitHub. I don't know if anyone has ever used GitHub. Has anyone used GitHub? Yes, wonderful. There's also platforms like GitLab, Bitbucket, Code Commit. That's Amazon's version as well. So these are services that are available where people are posting their code. So as they post and post and post their code, machine learning models can then be built against those data sets. Because the idea, like we discussed, box, we said, could you give an algorithm a lot of examples of faces, and eventually it will know how to identify a face. That's the same concept that is utilized when we start, analyzing quality of software. More and more and more code that works and that doesn't work. Data sets, and then we are able to determine when Fred writes his code. Fred, code is and it's able to do that using artificial intelligence. So that's the other aspect we wanted to quickly go through. The next thing we wanted to talk about was closed source versus open source software. I don't know if anybody has an understanding of what open source development is. What is open source development? No, you people need to talk to me, guy. You need to talk to me. Hey. Hi, ma'am. Yes.
Yes. Open source are those softwares we use for free. We don't pay for them. But closed source are those we pay for them. We pay for them and we are given the user rights or access rights. But they open are free.
Fantastic. I like that. But you maybe must data from a user perspective, like as the end user, as the beneficiary, and it. But the main idea actually between open source and closed source is a question of the source code itself. Is it open? Is it available? Or it's not available? So when software is open source, of course, when the source code is available, then any person who knows how to use a compiler can get that source code and compile it. So that's the consequence of having your software open. Can I really open source? It means when it's open source, it means it's accessible to everyone because the source code is available. So for example, source code is Android. I know most of us have Android phones. Whenever Android phones, can you raise up your hand? And this, right. Wonderful. My Android is an open source software. So it means right now, Kuda, if you decide, you know what? Dauda kuti nini dial a phone and this kufara ne by Buddha on my phone. I want to change it. I want it to come out at the top there. You can literally go online. You can fork the repository Android. You can get in there. Can you go to Java? Because it's predominantly Java and C++. And whether you can actually go and modify the Android operating system. That's because it's open source. The source code is available. Of course, you may not make modifications on the master branch because obviously maintainer who are credited with the ability to actually maintain rights. But basically, it's open source, so it's accessible to anyone. And there's a consequence because it's open source. No one pays for it. That's why you find Mrs. Munawaka's it's free. Then closed source software is software on your web. You will never know what you was saying. Source you will never find it online. And Ukaiwana, probably what you may try to do is reverse engineer it and decompile the software. And even when you do decompile it, probably some nuggets and some of it will be obfuscated. You can't actually read. So as a consequence, because your software, it's proprietary. In most cases, you can actually charge money for it. Because while people want to use it, they cannot reproduce it. They cannot replicate it. So they actually have to pay. So there is closed source software. There is open source software. Can we discuss my advantage and my disadvantage? Maybe. Just to pick your brains, guys. What are the advantages that you can think of? A good teacher project, for example, software. What are the advantages that you can think of? A good teacher open source. Yes, Brian.
I think with the open source, we can get new ideas. My idea would be
yeah, fantastic. You see, because it's open source, we will definitely enjoy the privilege of having, you know, more brains apply to the task, and we'll find different and better ways of doing something because we rely on the strength of our numbers. But Abashan, you wanted to say something? Oh, you wanted to say the same thing? Yeah. What else? What else can you think of? Chakuti, it's an advantage in open source.
In terms of market-wise, open source, since it's a free way, you know, so so close source in the mad.
Exactly. Wonderful. Exactly. So you see, an open source product is definitely going to reach a wider audience because it's a lot more accessible. Right? You see, so that's another advantage. I'd like to hear a lady's voice. I'm listening. Ladies. Don't just sit there and look beautiful. Say something. Yes, Lorraine.
It is easily distributed and also it is easily to be modified. And again, it is more likely to be secured if everyone is accessible to it.
Thank you. Thank you. Anybody else? Okay. Common disadvantages of open source. Let's talk disadvantages now. Yes, Brian.
I think open source not gonna consider viruses on your program or program.
Yeah, that is correct, but not necessarily gonna tikati oh Brian or in charge master branch. How major pull requests usati wa veta sata accepted TSA and did it. So risk is but rather risk is in production because the source code is available online. Someone can go through the source code and identify my vulnerabilities. And when they do that, they can then exploit them in production. So that's definitely a risk associated with some open source projects. Yes, Kuda. Emily, Emily.
Might be time consuming.
Open source is time consuming. How is it time consuming? Explain.
Program yacho right
okay, so let me see if I understand what you mean. You mean good when something is open source because there's a lot of collaboration in one whenever someone pull requests probably going through all those pull requests until we have a proper stable version yatokwanisa kupusha kurelease handiti. It's time consuming. It's definitely time consuming, and you definitely need a good team of moderators vanenge vari papa project yenyu, because hey, dambudziko rinozotanga munosvika boom pane 50 mapull requests, munhu wese ari kuti inini dhonza code yangu apa code yacho dololo. So you find that, yeah, it may take up a lot of your time. So thank you for that. What about closed source? What are some advantages that you can think of for closed source? Yes?
You want to have people copying or making replicas of our model engines and something like that.
Okay, definitely. You enjoy a great deal of exclusivity. I know in India, I'm a big fan of Apple. I like to use Apple products. They are so closed source like that. Panama products are wakawanda. Even though Swift, which is the language that they developed, is open source. Did you actually know that Apple developer Swift, which is open source? That's funny, right? But you find that hapana mangu mafoni ka anengane OS behavior like an iPhone. So that's definitely a benefit. What else? Yes, Trish.
It provides more security to the user.
Yes. I agree with that. My users anengane advantage yekuti apasina ma vulnerabilities are identify one, did it? So that one vadini va attack. So I think it's a very credible and it's a good advantage yatapua. What about my disadvantages? A closed source. Come on, anybody. I'm also looking at my disadvantages. Yes, Emily.
I think the disadvantage of closed source is that we cannot manipulate the code. You cannot change, you cannot edit, you cannot update the code.
Is that a disadvantage? Because probably vanokudza kuti patakazvigadzira takazvigadzira kuti zvishande zvichidaro ende uchida usingadi ndozvatinoda kuti zvishande zvichiita izvozvo.
So it becomes a disadvantage to us users.
Iwe uda kuchinjira chii? Nyora yako wega. Uda kuchinjira chii? No, I get it. It's definitely a lot trickier to introduce my features. I know what if, for example, iPhone yakazo introduce a feature yekukopa my one-time passwords anouya via text. So when you sign up for a service and then they send you a one-time password, it comes via SMS. On Android, it would automatically import that code onto that application. Message is pinned. So when you sign up for your WhatsApp and WhatsApp sends you that code, on an Android phone, it would immediately be taken and put right there. But on the iPhone, that feature came years later. So yeah, it was a disadvantage to iPhone users because they didn't get that feature, in time. They only got it much later. So yeah, it's definitely a good point that you raised there. Does anyone still have anything to say on closed source and open source development? Is that Mr. Maoneke? Mr. Maoneke, you have something to say? That is correct. That is correct. Ma'am, Mrs. Muja, you have something to say as well?
Yeah, I wanted to say so, it's expensive. You have to have a license. And
Definitely.
most upselling, you have to use it after paying for it.
Exactly. So that's the nature of proprietary stuff. But in my experience, you get value for your money. Many times we want to resort to open source software, but some of the limitations are repo, and sometimes when they have special algorithms built in, we don't actually enjoy them because it's negative outside. Probably they hire a group of innovators like yourselves. Vanonyatsozikanwa kunzi vakomana vanorova nevasikana vanorova vanonyora code chaiyo. So those are the guys that actually develop some of these special modules that we don't have access to in the open source world. So yeah, kudhura hayo, but sometimes kudhura ikoko brings you better value. So that's about that. So exercise yakanzi critical and analytical thinking challenge. Since it's a challenge, and we have content James 31, which is today we have to cover, I will have to prepare it per side, then send you a link. Because what this exercise is supposed to do, it's supposed to sharpen your critical thinking skills. Because you need to have good critical thinking skills. Kana takugadzira macodes edu, maprograms edu, or even when we start talking about problems and problem solving. You know that famous example, yekunzi une mbudzi nebere nechimera, and you have to cross a river. You can only carry one at a time. I don't know if anyone still remembers that that little riddle. Does anyone still remember?
Yeah.
And did it? So it challenges you to think critically. Okay, what am I supposed to do? Oh, ndotanga kuenda nebere. Ndikaenda nebere, mbudzi inosara ichidya mumera. So what do I do? Let me first take mumera. But ukaenda nemumera, mbudzi inosara ichidya. So that kind of thinking, that's the same kind of thinking that you need to adopt when you start designing my systems and writing my programs. So I will prepare that link separately and I will share it with you. I did it. So let's jump into today's content. Today's content is Web 101. We are talking about the internet now. Kana kuti ndaifanira kumbokupai 5-minute break or something. Ndizvo? Tofamba here. Kana kuti mona mbonomwa mvura ndogona kupai 5 minutes mungo just to freshen up because mamwe zviri kuwandisa. Lorraine. Watiko Lorraine?
5-minute break.
5-minute break, Anditi. Okay, so quickly take a 5-minute break, Anditi. Imai mvura chimbofemai nekudini. Then we are proceeding at 21 minutes past 12. Anditi. Thank you guys. Okay, guys, 5-minute break area pair. Are we ready to proceed? Are we ready to proceed?
Not yet, 1 minute.
Okay, that's all right.
You can start with some project.
Okay, thank you very much. All right. How was the break? Don't I'm going busy, ma. Apana mobuda imo. Okay, guys. Now we want to talk about the internet, the World Wide Web. And it. So, guys, internet is network, which spans globally, right? It's the biggest network in the world, and it's got so many types of devices that are interconnected, and it's got so many kinds of computers, cell phones, IoT devices, so many little pieces that come together to form this whole big thing that we call the internet. So, just as an overview, we want to talk about the architecture or what it's built up of, and it's top down. So, in discussing this, you know there's the physical aspect of it, and then also the software side of it. Can anyone tell us some of the building blocks, the internet, some of the components that come together? What are some of the things that you know definitely off the cuff what you need in order to get the internet? Yes.
My router, my switch, that access nodes, my gateways, and also, and then my cables, and also my servers. I think that's all.
Okay. Anyone from my other group B? I don't want to think of any other thing. Like what we need to sit out of the internet. Okay. So guys, I think the most fundamental thing that in order for us to actually implement an internet, standards, we need to have standards. I know Guti test a plug kumba and a plug around in a square. Those are examples of my standards. Because if we want things to interoperate or things to work together, then we need to define some kind of standard. And luckily for us, today my protocol and my protocols are these are like my standards, like so when we say HTTP and Trish, wakamona bakanzi HTTP. Zine zvakanyorwa pai. Pa-address website anditi exactly. So HTTP is a type of a protocol. It's an example of a protocol. Does anyone know what it stands for? Yes, Emily. HTML. What are HTML? I mean HTTP. Yeah. HTTP, yeah. Exactly, anditi. Hypertext transfer protocol, anditika. That's an example. E protocol yekuseva nayo machi my web page. And when you find that it's got an S at the end, then they're just simply saying, the secure sockets layer that it's going through. So it's more secure, like the communication is not sent in plain text. Web pages. Can anyone give me another example of a protocol? Shanda by internet. TCP/IP. TCP/IP collection. It's a collection, so it's like a collection of all of them. Let's try to find one. Okay, there's another one, the FTP. I don't know if you've seen it. FTP. FTP is another type of protocol. This one mostly when people are transferring files, you are uploading my files to a server. Drag or drop. Unlike that you upload online, you actually have to use an HTTP file post request. No. Keep up on straight directly FTP client. That's another type. There are also other protocols like UDP and the idea behind these protocols is so that we have governing rules. It's not how we can do something. So you will find whenever you see HTTP, you're going to be served a web page, you're going to be served content through your browser. That's your HTTP. If you're going to go your FTP, you're going to use your FileZilla, for example, or CyberDuck, for example, because no protocol yacho, and when you design an FTP client, you have to do it while you adhere to the rules of that particular protocol. Anyway, the overview of what we're trying to talk about here is, in order for the internet to work, apart from all the physical stuff that you mentioned, Kuda, we also need standards. We also need my protocols, because now do not define how we then use the internet and how we interact with it. So the next part, we're talking about e-commerce, e-learning, and e-governance. What comes to your mind when you hear e-commerce? Oh, guys, ask some numbers for e-commerce. Mama, this is not so. I mean, I take it. I still can't hear anything. E-commerce. Yes, Clemens.
Yeah, I think of buying and selling electronically.
Okay, wonderful. That is correct. E-commerce, we're talking about taking commerce, the everyday, day-to-day commerce that we know. We will be then taking it to the to the digital. Okay, and what about e-learning? And then we talk. We also have e-governance, e-governance. I think this speaks to the broader vision. In our last session, Mr. Mtemela, when he was talking about, Kunzi, like makakwizwa ndege. I may not name because vakataura zvinhu zvakanaka stereki pamusoro penyu muchinzi ndimi chakanzira masolution. Saga, it's part of that where the government interacts with citizens using, of course, my tools. So you find that to some extent our government it tries, not try, but then again, as long as it's so to participate, being the young innovators, they will always lag behind because I don't think they even know some of the things that we see now we know. So then we have search engines. Can anyone give me an example of a search engine? You see Google. Bing, exactly, wonderful. Diana, it's our Bing. Okay, wonderful. Tell me another one, anyone. Mundiani ngataura ndotenga drink bandiri kuuya kuchipiri. Hanzichi.
Firefox.
Aiwa, Firefox haizi search engine.
DuckDuckGo.
DuckDuckGo is a search engine, yeah. So, Brian, I owe you a drink, bandiri kuchipiri. Yes, Clemens, you wanted to say something?
Yahoo.
Yes, Yahoo. Yahoo was actually the first. It was one of the first. But how could develop an algorithm Yahoo. So Dringra Clemens, Dringra Brian. Come on, ladies, apana now take a word drinking. Yes, Trish.
Yandex.
Yandex. Yandex. Yes, exactly. Okay, Saga, 3 madrinda kwana, indozo pera man. I think Murugun the idea behind the question, like what is a search engine? You actually understand, oh, a search engine is a service that you use to look up whatever keywords that you want to look up. And I don't know, the other time, Panandri was talking about how we can rank. I was giving an overview, yeah, course content. Could discuss when we start talking about content creation and media, social media. How can we also take advantage of some of the algorithms? Yeah, could content rank higher and the like. So you know that they paginate my results out. They'll probably have a block of 13, 14, 15, 20 results. Then they go to the next page, next page, next page. So those are your search engines. And those are usually the starting points. Anything pachi internet. Okay, so let's talk about social media. In Indo now talk about social media platform and town. Then in Mimos town in your did that on Facebook, did that on Twitter, did that on Instagram, did that on TikTok, did that on okay, depending on my example in my social media platform. Yes, Kuda.
Satellite.
Can we share that? They try so hard. But you people are so thick-headed, very resistant. Okay, anyone else? Yes, who's that? I want to do that. Out of the tabs. Kundai. Okay, yes, Kundai. WeChat, exactly. That's a good one. Yes, Lorraine.
LinkedIn.
LinkedIn. Ooh la la. That one is really good because it's also professional. In social media, you're not professionals. Your future is very bright, Lorraine. Anyone else? Yes, Clemens. Huh? YouTube. But YouTube is not a social, it's not necessarily okay, they have a social aspect, but it's not necessarily a social media. YouTube. Though my live chat, the live chat is probably the only social media part of it, maybe because it's a content platform, it's a video content platform. No, not necessarily. So I reject YouTube. Right? Anyone else? Yes, Trish.
Key interests.
Okay, Pinterest. Yeah, Pinterest is it's okay. I'll accept it. I'll accept it because you can share your board, and you can also invite others to collaborate on your board. Okay, yeah. So you guys, I think you're using a lot of social media, and social media. In any one of my favorite social media platforms, the Reddit. I don't know if anybody uses Reddit. Reddit tagline now, Reddit. It's called Reddit. It's Red, REDDIT. It's reddit.com. Yeah. It's they call it the front page of the internet. It's one of my personal favorites. I don't really like Facebook. I don't really like Mamacho, but Reddit is really good because like you don't have to tell the world about yourself. You just need to discuss it. So that's why I like Reddit. It is less about personal life and more about fun stuff that you want to discuss online. Anyway, those are examples of my social media platforms I needed. We all know the purpose of social media. Oh, by the way, someone at Firefox earlier. Firefox is not a search engine, but rather it's a what? It's a what? Thank you. Thank you. Right, let's go back on the collaborative spaces now. I did it. This is the last part which we'll talk about today. Then we break lesson Yedu. Mangwana and the day after, we'll deal with the other remaining items. Gaming, streaming platforms, my useful shortcuts and services, safety and privacy on the web, cybercrime, Web 3.0 and beyond, where we talk about crypto, NFTs, and the metaverse. Israel will discuss them in the next 2 days. But the last thing we're going to discuss today are these collaborative spaces. Okay, so when we talk about collaborative spaces, we're talking about platforms where you can actually go and work, be productive. Zoom, and Zoom is an example of a collaborative space because we can actually connect, we can chat, we can share material, we can share screens and it. Now, there are so many of these types of applications are out because during the pandemic, of course, people had to adapt. They had to change the way they do their things. Sunday remotely and online. So when you hear collaborative space, what do you think of? Anyone? Pane any bell no ring when you hear of collaborative space? As silent as the grave. Okay. So has anyone ever used the platform, the Slack? Slack, so it's slack.com. That's Slack. Let me just open it here. Right. And then we're going to screen yangu irabe. All right. So, Paragamo ishandise the website. Okay. All right. So this is an example of a collaborative space, in the Slack, Aditi. So what is it about, Aditi? If we come per section around the features, Aditi, you can create my channels per Slack, Aditi. You can use, the Slack Connect to collaborate with your teams or other companies the same way you do with your own teams, teams of your own, Aditi. You can send my messages, you can do my voice and video calls. And then there's accessibility. Accessibility, whenever you hear the word accessibility, what we'll be basically talking about, people who probably have disabilities or are handicapped in a way. So accessibility is all about making our products and services more accessible to those people. And you know how to supermarket and accessibility. Pane steps and then for ramp, where they actually can go. So it's an accessibility feature because the idea is you don't want to discriminate against one. Supermarket. On your phone, for example, you're able to increase your font size. That caters as well for accessibility. Even my features, your phone can actually read to you. The idea is that it's accessible. So Slack is a very good example of a collaborative space. And probably I'll set up a Slack channel just so that you guys get a feel of it as well. And also see how can we work together faster and better to answer Slack. Because until you see Slack is more secure than email, it can perform the roles of an email service, even though it is a separate website. It also allows you to do my calls, Zoom. It also allows you to create my channels. Are public, are private? You can, have one-on-one conversations, or you can have one-to-group conversations. So these are spaces that are designed for people to be productive. Yeah. Log in, this is basically what it looks like. I don't know if you can see clearly, but yeah, this is basically what it looks like, where you can actually see my messages, where you have been mentioned, any drafts of any work that needs to be done. And you can see, you can send my documents instantly. You don't even need to leave the Slack. You can do everything from within Slack. And it also has assistant bot, which you can actually interact with on the side so that you can get quick answers to probably quick questions on the go. So these are examples of collaborative spaces, and they are very helpful because they boost productivity and they allow us to do a lot more. Platform. You'll find with WhatsApp is trying to build towards that, because WhatsApp the WhatsApp web, and they also have a desktop application now. And if you join the beta program, you're actually able to use your WhatsApp phone on your computer. So this shows the direction that they're heading in. We are working on developing that collaborative aspect, because you then be able to work on your computer exclusively, share my documents by WhatsApp, share my audio, share all the stuff share by WhatsApp, and even conduct our group calls. So these are examples of collaborative spaces and what they are useful for. So I don't know if you have any questions, if anybody wants to ask any questions after today's lesson, or kanapana any contribution, please feel free. Thank you. Okay, we are all silent, right? Okay, so fantastic. Okay, thank you so much for your time, everybody. I know kuti mama nengura vakapedza last week yese musingauyi kuchikoro. I tried as fast as I could kuti ndikeche up ndikubatanzirei. So I know that the aspect that we've skipped that we need to cover is that critical and analytical thinking challenge. So I'll set it up and prepare it for you. And then tomorrow, we are going to do gaming, streaming platforms, useful shortcuts, safety on the web, cybercrime, web 3.0, and the recap, Mangwana. And then the day after, tovatanyora assessment yedu. I did it. Okay, guys. So any questions? Anyone wants to say anything before we finish? Before we all leave? Okay, guys. So let's talk more, Mangwana, and enjoy the rest of your day. Hey?
Thank you, sir.
Okay, bye-bye.